How do you figure out the equivalent resistance of an electric circuit? Find out right now.
Hi, I'm Dr. Matt. There are no lectures here. I just solve problems. Homework problems to help you understand how to do them. Electrical engineering at your service.
In this problem, we have a simple resistive circuit. We start with a 63 volt power supply, and then we have a 5 ohm resistor, 2 ohm, a 15 ohm, a 4 ohm, 3 ohm, 2 ohm, 4 ohm, 2 ohm, 4 ohm, and another 4 ohm resistor. So the question is, first off, determine the equivalent resistance of this whole circuit, and then determine the power delivered by the source. In order to do that, we have to use a series of problems. We either use a series rule or a parallel rule. So we want to determine which resistors here are in series, which are in parallel. Mostly we're going to look at nodes and branches to determine this. Usually the best way to start out a problem like this is at the end, because you're not going to figure out anything. You can't look at this and say, oh look, these two look like they can go together, but you've got something back here, so you don't know what this equivalent resistance is. You don't know what this is, you don't know what that is at this point. So you look at places across here. No, can you figure that out? No. But there's something right back here we can figure out. I've got a 4 ohm resistor in parallel with another 4 ohm resistor, so I can sort of redraw that circuit and make it look like, let's just take these little guys right here. Here's my 2 ohm resistor. I'm just going to take this section of the circuit and look at it. And then I've got a 4 ohm right here. There's a 4 ohm. There's another 4 ohm. And we've got a little 4 ohm resistor that goes across here. So we're just going to look at this little section right back here. What this looks like is I've got 2 resistors that share a node right here. Now, that share 2 nodes. You don't want to get fooled by the triangle shape here. What happens is I've got a node A and a node B right here. So these 2 resistors are in parallel. Being in parallel, of course, I can solve the resistance, the R equivalent for that, and that is R equivalent for that is going to be 1 over 4 plus 1 over 4. Well, this just comes out to 2 over 4. When we flip it up, that comes out to 4 over 2, which is equal to 2 ohms. So now I've got an equivalent circuit for this little guy right here. Becomes just a resistor right there. So let's redraw that. There's 2 ohms. And then there's another. This gets replaced with the 2 ohm resistor. And then my 4 ohm over here stays the same. So now we've got these 2 little guys here in series, and that's just straight add up. So our equivalent for that is going to be 2 ohm plus 2 ohm, which is just equal to 4 ohm. Right? So we redraw that, and we're going to redraw it this way. I'm going to push this guy up a little bit, and start over. I'm going to push that up, and then I'm going to redraw this section of the circuit is going to be look like this. There's my 4 ohm. This 2 plus 2 goes to 4 ohm, and now it looks like this, 4 ohms, right? And here's that of course is the rest of the circuit out there, and we know already that 4 ohms in parallel with 4 ohms is equivalent to a 2 ohm resistor, because we already worked that out. So 4 ohms in parallel just becomes this right here. Okay, so let's replace that in our other circuit. We'll redraw our original circuit. Starts with a 63 ohm power supply, or 63 volt power supply, and then we have a 5 ohm, 5 ohms, 2 ohms, 15 ohms, and then we have our 3 ohm here, 2 ohm, and then we have this 4 ohm across here, and then we're going to replace, you see what we're doing, I'm redrawing this part right here. This whole section is where we cut it off last time, so we're going to add what has become of this, which is basically this little 2 ohm resistor on the end. So I've redrawn this circuit to an equivalent version. Now I have a 2 ohm resistor in parallel with a 2 ohm resistor, and that's just going to be our equivalent is equal to 1 over 1 over 2 plus 1 over 2, which is going to be 2 over 2, which is just going to be equal to 1 ohm. So now this part becomes 1 ohm, and we'll redraw that. I'm going to cut this off. Let's see. I don't know if we should cut that off. Let's take it from right there. Here's our 3 ohm, and then 2 ohm plus in parallel with 2 ohms just becomes 1 ohm. So there's 1 ohm. And then I still have this 4 ohm resistor right here. Alright? And now we've got, what happens here is we have a 3 ohm in series with a 1 ohm, so that just our equivalent is equal to 3 ohms plus 1 ohm, which is straight up 4 ohms. And what that appears as is, it goes to this circuit right here. It becomes, here's our 4 ohm, and that is in series with 3 plus 1, another 4, or in parallel with another 4 ohm resistor. So that, of course, we know from parallels, we've already worked it out, is, of course, a 2 ohm equivalent to a 2 ohm resistor. So let's redraw our circuit diagram. And the key to this is just redrawing your diagram. Most of it is just redrawing it until you figure out where you're at. If you try to do this the hard way or draw on top of things, you're just going to make a mess out of things. So now I'm back to my power supply, 63 volts. Here I have a 5 ohm. Here's my 2 ohm. There's my 15 ohm. 5 ohm, 2 ohms. And I've already looked at this right here, this circuit, and I've already said all of this becomes a 2 ohm resistor. So now that's starting from right there. I'm looking at that, and what you're going to see is that is a 2 ohm resistor parallel with a 2 ohm resistor. Now, I could have put that into the previous calculation. I could have just added that in, but I didn't, because you can work this either way. If you have resistors in parallel, you can work them out 1 at a time, 2 at a time, 3 at a time, 4 at a time, however you want to do it. Doesn't matter. Here I've got a 2 ohm in parallel with 2 ohms, so our equivalent is equal to 1 over 2 plus 1 over 2. Again, that comes out to 2 over 2 or 1 ohm. So now I redraw my circuit. This becomes 63 volts, a 5 ohm, a 1 ohm, and a 15 ohm. That becomes a series circuit, so our equivalent is just equal to 5 plus 1 plus 15 ohms, which is equal to 21 ohms. So that's the answer to this question. Our equivalent of this whole circuit is 21 ohms. That answers the first question. The second question is, determine the power delivered by the source. Well, P is equal to IV, and it's also equal to V squared over R. Either one of these we can work with. No, we don't have IV yet. Let's determine the current first. So I is equal to V over R, which is going to be 63 over 21. So 63 volts over 21 ohms, and that means I is equal to 3 amps. So that's not one of our solutions, but we need that in order to get it. Now we can solve P equals IV over here. So power is equal to 3 amps times 63 volts, and that comes out to 189 watts, if I did my math correctly. Yes. And it also is equal to, P is also equal to V squared over R, which is equal to 63 squared divided by the 21 ohms, and that also comes out to 189 watts. And I'll throw a calculator in there to make sure, because we're like 63 x squared divided by 21 is 189. So that is the answer. That is the answer to the second part, 189 watts. Whenever you write your answers down on your papers, be sure and square them off so the grader can see the answers quickly and easily. That nothing irritates a grader more quickly than have to hunt through your chicken scratch to find the answer. So, that's it.
Thanks for watching my program.
If you like my videos, be sure and subscribe to my YouTube channel. And for an organized listing of my YouTube videos, go to my website, www.wherearemyplacebos.com, and click on videos. Have a great day.